Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the named reactions involving alcohols and phenols. Especially here, I am going to discuss in detail about the 7 types of reactions which generally includes Kolb's reactions, Riemann-Tiemann reactions, Bowman reaction, Fischer Esterification, Grignard reaction, haloform reaction, and Lucas test. So coming back to Kolb's reactions, Kolb's reaction generally involves the conversion of phenol into salicylic acid, whereas Riemann-Tiemann reaction involves the conversion of phenol into salicylaldehyde, and it is also possible to convert phenol into salicylic acid. Coming to the Bowman reaction, it is highly useful for the conversion of phenol into phenyl benzoate. Coming to Fischer Esterification, alcohols can be converted into corresponding esters. Grignard reaction is highly useful for the conversion of alcohols into hydrocarbons. Especially alkanes can be obtained by treating alcohol with the Grignard reagent. Haloform reaction is highly useful for the conversion of ethyl alcohol into chloroform. And finally, coming to the Lucas test, it is highly useful to distinguish primary, secondary and tertiary alcohols. Now I am going to discuss in detail about the each and every reaction. So coming to the Kolb's reaction, it generally involves the conversion of phenol into salicylaldehyde. So let us consider phenol. Phenol is initially treated with alkali. Let us suppose it is treated with sodium hydroxide. Then what happens? It results in the formation of sodium phenoxide. So phenol on reaction with sodium hydroxide, it results in the formation of sodium phenoxide. What is the major difference between phenol and sodium phenoxide? So it is phenol on treatment with NaOH, it results in the formation of sodium phenoxide. Especially this sodium phenoxide is highly reactive when compared with the phenol. Then what happens? So undoubtedly sodium phenoxide is highly reactive and it is carrying negative charge on the oxygen. That means this phenoxide ion will act as electron rich species and hence it easily undergoes electrophilic substitution reactions. So here when it is treated with carbon dioxide followed by the hydrolysis in the presence of an acid, in the ortho position acid group will be introduced. So what is the importance of phenoxide ion, students? Phenoxide ion is electron rich species and it is highly reactive. So it easily undergoes electrophilic substitution reaction and hence whenever the sodium phenoxide is treated with carbon dioxide followed by the hydrolysis in the presence of H plus ion, what happens? Always acid group will be introduced at the ortho position. So the adjacent position is called as the ortho position. Then it results in the formation of salicylaldehyde. So what is the name of the product? Salicylic acid. Okay, phenol on treatment with alkali followed by carbon dioxide and hydrolysis in the presence of an acid, it results in the formation of salicylic acid. Students, is it clear about the Kolb's reaction? So what is the importance of Kolb's reaction? It is possible to convert phenol into salicylic acid. Now let us discuss in detail about the RTR reaction, that is Riemann-Tiemann reaction. So in this Riemann-tieman reaction also, the starting material is phenol. So what is the starting material? Here also we will use phenol. So this phenol on treatment with chloroform in the presence of aqueous NaOH, what happens? Due to the reaction with chloroform, an aldehyde group will be introduced at the ortho position. So what happens whenever phenol is treated with chloroform in the presence of NaOH? Simply aldehyde group will be introduced at the ortho position. And in order to get the salicylic aldehyde, it should be hydrolyzed in the presence of an acid. So finally what happens? It results in the formation of salicylaldehyde. So whenever phenol is treated with chloroform in the presence of sodium hydroxide, what is the final product, students? Salicylaldehyde. And always remember that depending upon the nature of the reagent used, it is also possible to get the salicylic acid. Let us see how salicylic acid can be prepared by using Riemann-tieman reaction. So here also the phenol is taken as the starting material. In this case, it is treated with carbon tetrachloride in the presence of aqueous NaOH. Then what happens, students? Always remember, if phenol is treated with chloroform, then it results in the formation of salicylaldehyde. So aldehyde group will be introduced at the ortho position. Whereas if phenol is treated with carbon tetrachloride, what happens? Acid group will be introduced at the ortho position. So phenol on treatment with carbon tetrachloride, acid group will be introduced at the ortho position. And in order to get the salicylic acid, it should be followed by hydrolysis in the presence of an acid. And thus finally it results in the formation of salicylic acid. So phenol on treatment with chloroform, it results in the formation of salicylaldehyde. Phenol on treatment with carbon tetrachloride, it results in the formation of salicylic acid. And the reaction is called as Riemann-tieman reaction. Is it clear about the Riemann-tieman reaction, students? Let us study about the Bowman reaction. So what is the named reaction? Bowman reaction. In this reaction, phenol is treated with benzoyl chloride. So in this reaction what happens? Phenol is treated with benzoyl chloride. Then what happens? Remember students, the reaction takes place in the presence of sodium hydroxide. It is a simple reaction, just elimination of HCl takes place. So whenever phenol is treated with benzoyl chloride, what happens, students? Just in the presence of alkali, HCl will be eliminated. You just join the two molecules. Students, can you name this compound? It will be called as phenyl benzoate. So what is the name of the product? Phenyl benzoate. So whenever phenol is treated with benzoyl chloride, it results in the formation of phenyl benzoate in the presence of sodium hydroxide, and the reaction is called as Scott and Bowman reaction. Let us see Fischer esterification. Simply what happens in esterification reaction, students? In esterification reaction, acid reacts with alcohol in the presence of an acid, then elimination of water molecule takes place. With the result, an ester will be formed. So during Fischer esterification process, what happens, students? Acid reacts with phenol in the presence of sulfuric acid or HCl. Then what happens? Water molecule will be eliminated and it results in the formation of ester. Let us see one example, that is, whenever we consider acetic acid, it reacts with ethyl alcohol. Remember that in the presence of an acid, either HCl or sulfuric acid, OH from acid and hydrogen from the alcohol will be eliminated as the water, and finally it results in the formation of ester. Can you name this compound, students? It can be called as ethyl acetate. Is it clear, students? And remember that it is also possible alcohol, when treated with acid chloride, it also results in the formation of ester. So in the place of acid, we can also use acid halide. So alcohols also reacts with acid halides, which also results in the formation of ester. Here, which molecule will be eliminated? HCl will be eliminated. And remember that this reaction takes place in the presence of pyridine as the catalyst. So, chloride from the acid halide and hydrogen from the alcohol undergoes elimination, and that results in the formation of an ester. Is it clear about the Fischer esterification, students? Next, we will discuss about the Grignard reaction. So what is the other reaction? Grignard reaction. Can you remember the importance of Grignard reaction, students? So in Grignard reaction, alcohol reacts with Grignard reagent. So what is the general formula of Grignard reagent, students? RMgX. So what is the formula of Grignard reagent, students? It is RMgX. So in Grignard reaction, the alcohol reacts with Grignard reagent. Here what happens? MgX will react with OH, and then what happens? It results in the formation of, it reacts with RO, so that it results in the formation of hydrocarbons. That means it results in the formation of alkanes. Mg, just this OR group will be inserted between Mg and X. So during Grignard reaction, what happens? Just hydrogen from the alcohol reacts with the alkyl group and it results in the formation of alkane. Let us see one simple example. Let us consider a Grignard reagent and also ethyl alcohol. Students, can you guess the product? From the above general reaction, it is very clear that alkyl group from the Grignard reagent reacts with the hydrogen of the alcohol and it results in the formation of alkane. And coming to the remaining product, MgOC2H5I. So in this way, it is possible to prepare methane from Grignard reaction. Is it clear, students? What is the importance of Grignard reaction? It is highly useful for the preparation of alkanes. So what is the importance of Grignard reaction? We can prepare alcohols by using Grignard reagent and alcohol. Let us discuss about the haloform reaction. So coming to the haloform reaction. In haloform reaction, what happens, students? Alcohol is treated with bleaching powder. What is the formula of bleaching powder? Calcium oxychloride. Especially moist bleaching powder is used at high temperatures. So that means whenever ethyl alcohol is distilled with moist bleaching powder, then what happens? It results in the formation of chloroform. So in this haloform reaction, what happens, students? Whenever the ethyl alcohol is distilled with moist bleaching powder, then it results in the formation of chloroform. And remember that it is also possible to prepare iodoform by using iodine and potash. So here also the starting material is ethyl alcohol. So when it is treated with iodine, it undergoes oxidation and it results in the formation of acetaldehyde. So in the first step, what happens? Ethyl alcohol will be converted into acetaldehyde. And in the second step, acetaldehyde again reacts with iodine and it results in the formation of an intermediate product. And finally, in the third step, this intermediate product reacts with potash and thus it results in the formation of iodoform. Is it clear, students? So whenever ethyl alcohol is treated with iodine in the presence of potash, it results in the formation of iodoform. And finally, we are going to discuss in detail about the Lucas test. What is the importance of Lucas test, students? It is highly useful to distinguish primary, secondary and tertiary alcohols. Now tell me, what do you mean by primary, secondary and tertiary alcohols? Primary means if the carbon atom is attached to another carbon atom or none, then it is called as primary alcohol. So whenever a carbon atom is attached to another carbon atom or no carbon atom, then it will be called as primary carbon atom, and here alcohol is the functional group, so it can be called as primary alcohol. And coming to the secondary alcohol, secondary carbon means whenever a carbon atom is attached to two other carbon atoms, then it will be called as secondary carbon atom. and the alcohol is called as secondary alcohol. And in the similar way, whenever if the carbon atom is attached to 3 other carbon atoms, then it can be called as a tertiary carbon atom, and the corresponding alcohol is called as tertiary alcohol. Is it clear about the primary, secondary and tertiary alcohols? In primary alcohols, what happens? A carbon atom is attached to only one carbon atom or none. Then it is called as primary alcohol. If the carbon atom is attached to 2 other carbon atoms, then it is called as secondary alcohol. So, if the carbon atom is attached to 3 other carbon atoms, it can be called as a tertiary alcohol. So, it is possible to distinguish primary, secondary and tertiary alcohols from each other through Lucas test. So, in this Lucas test, what happens? Alcohols will be treated with concentrated HCl in the presence of zinc chloride. Can you guess the product? Let us move on to the secondary alcohol. In the case of secondary alcohol, what happens? Whenever secondary alcohol is treated with concentrated HCl and zinc chloride, then what happens? Initially, it results in the formation of a carbonium ion. What happens initially? It results in the formation of a carbonium ion by the elimination of OH group. Then Cl will be added. So what is the final product? Corresponding halide will be obtained. And coming to the tertiary alcohol, here also what happens? OH group will be eliminated and Cl group will be introduced. So, we will get the corresponding tertiary chloride. And coming to the rate of the reaction, students always remember that here whenever the OH group is eliminated, what happens? It results in the formation of carbonium ion. So, what is the structure of carbonium ion in this case? A positive charge will be developed on the carbon atom. And remember that here this carbon atom carries the positive charge and central carbon atom is attached to 3 other carbon atoms and hence it is highly stable. Thus, whenever the tertiary alcohol is treated with concentrated HCl in the presence of zinc chloride, it results in the formation of more stable carbonium ion immediately. So, this reaction takes place immediately. Then how to identify whether the reaction takes place or not? So, it results in the formation of turbidity. So, here whenever a tertiary alcohol is treated, then it results in the formation of turbidity immediately. So, immediately a turbidity will be formed whenever the tertiary alcohol is treated with Lucas reagent. And coming to the secondary alcohols, here also turbidity will be formed, but it will be formed after some time. So, after some time, what happens, Andy? A turbidity will be formed. And coming to the primary alcohol, at room temperature, there will be no reaction. Why? So, when you compare the carbonium ion formed in the case of tertiary alcohol, it is being stabilized by 3 alkyl groups. And coming to the secondary alcohol, it will be stabilized by presence of 2 alkyl groups. But coming to the primary alcohols, it is having only 1 alkyl group and hence at the room temperature, there will be no reaction. But on heating, what happens? The rate of the reaction increases and it also results in the formation of corresponding halide. Is it clear, students? At room temperature, there will be no reaction. So, primary alcohols show no reaction at room temperature with Lucas reagent, whereas secondary alcohol results in the formation of turbidity after some time and coming to the tertiary alcohols, they form turbidity immediately. So by this reaction, it is possible to differentiate primary, secondary and tertiary alcohols. Is it clear, students? If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.